Can we have the presentation, please?
DG Clause, distinguished guests, ladies and gentlemen, good afternoon and Jai Hind. At the outset, I would like to express my gratitude to the organizers for having given me an opportunity to share my views on the emerging technologies in quest for defense dominance. I'll say very seminal topic, and I think this topic will always remain seminal whenever we discuss, whether it was 10 years back or 10 years hence, because technology is which always affects the way we conduct our warfare. Okay. Since I've got only 15 minutes, the topic is actually quite vast. There's a lot to cover. So therefore, I'll just focus on certain specific things and cover very few ones so that we are able to focus on what is immediately emerging, what is important. Just let's have a look at the recent past, what has happened in the recent past. We all are aware of September 24, this Hezbollah pager attack. This was the first time which demonstrated the increasing convergence of cyber and physical systems. Just about less than 2 months back, again in Venezuela, the power of offensive cyber. And now in this ongoing, the US-Iran-Israel war, it has demonstrated a fully networked multi-domain war involving space assets, AI-enabled targeting, drone swarms, layered missile defense, electronic warfare, and cyber operations, in a way indicating how future high-intensity conflicts will be fought. And if we just look at the kind of targets and their locations, which were engaged almost simultaneously, the Kermanshah province in western Iran, the location of mobile ballistic missile launchers, which are detected by ISR assets, Isfahan region, IRGC logistics depots and missile support facilities, and Tehran outskirts, which was a command and communication nodes. So what do the statistics say? Some of the statistics. The strike decision cycles have been compressed to just about less than 10 minutes for time-sensitive targets. Israeli Air Force reported 600 plus Iranian military targets struck, many of them detected through rapid ISR fusion. 541 drones launched toward Israel and regional targets, 506 intercepted by Israeli and allied air defenses. So both the technology and the counter to it. 165 ballistic missiles launched towards regional targets, 152 intercepted, nearly 90% interception rate. So this is what is happening when we are talking of non-contact kinetic warfare. And across recent global conflicts, one pattern which is actually common is that spectrum is contested right from the first minute. Drones appear in swarms and not singles. Communications are jammed right from the beginning, and the GPS is unreliable or denied. And it's not only this, if we look at it, the way technology cycle is also evolving at such a fast pace. If you look at FPV drones, in just 18 months, it has actually evolved from zero to dominant to a dominant weapon. And not only the FPV, along with it, the ammunition, the warheads which are being used in that, and the various other AI-related softwares used in that. So what are the emerging technologies which are impacting warfare? If we, what I said was about the kinetic non-contact. But once it comes to, say, land border sharing countries, and if it comes to a contact warfare, it lands into the domain of the autonomous weapons. And what is shown on the left side, you must read through them, is what the summary of the various doctrines of various countries, whether it's USA, UK, Australia, China, and what it brings out. And the final line in that is that over time, tactical level of warfare may almost be comprised of robots. Whether yes or no, I think only time will tell. The other aspect is that the 20th century warfare, which was more of a industrial warfare, is now evolving into a 21st century, the algorithmic warfare. Now, this is where a cognitive warfare, when strategic advantage comes from the superior sensing and targeting. And in this modern warfare, one of the most important things is the data. So data, if we see, is actually as critical as firepower. And also AI-enabled predictive logistics, not only for yourself, but also to actually be able to predict the enemy's entire course of operations based on his logistics. So if we see, it's actually a bouquet of technologies. And I've just listed some of them. And none of these technologies today are actually working in isolation. It's a convergence of all these technologies which are creating the impact. So more than technologies, actually, it is the innovative application of these technologies which always brings that surprise, that element of newness into the battlefield. The autonomous systems in Ukraine, we have seen that how AI has got applied in whether it be targeting or in surveillance. And also the first one in somewhere in December 24, wherein an autonomous robot being guided by a drone was actually used for a kinetic role. So that is how the autonomous systems are actually coming into, they are almost becoming now ubiquitous across the three domains of air, land, and sea. Something no more science fiction. What is shown over here is what we call it as the flying amphibious robots. Now, this is a combination of various cobots which can work together or individually. As you can see here in the various photographs, they can fly and hover above the surface. They can morph into a ball and roll on the surface. They can go in the subsurface voids, navigate through them. They can float on a lake surface, and they can propel under an ocean. So all depending on the kind of application we have, the kind of role, this is what all can be actually achieved. No more a matter of fiction. Well, now coming on to one major aspect, communications, because in everything, whatever today, communication is the most important aspect. Unless all elements are able to communicate with each other, really can't do anything. So in communications beyond line of sight or over the horizon, communication technology is what is emerging. The high data rate communications beyond line of sight and over the horizon link that traditionally actually based on HF, satellite, airborne repeaters, and troposcatter communication. However, because of the disadvantages which they have, the constraints such as channel capacity, reliability, energy efficiency, etc., there is a requirement for development of flexible solution which may switch between multiple options. The other aspect is high capacity backhaul connectivity in the range of about 200 to 500 Mbps, enabled through communication repeater payloads on satellites and high altitude pseudo satellites, that's HAPS. This will be something which is critical for extending reliable communications to remote, maritime, and contested battlefields. Actually, these payloads, they leverage the high throughput RF and optical feeder links, steerable high gain antennas, and adaptive modulation to relay voice, data, and ISR traffic between dispersed forces and core networks. So these satellite repeaters, actually, we see they provide a wide area and beyond line of sight coverage, while the HAPS, they offer low latency and regional backhaul with flexible positioning and rapid retasking. Direct to mobile satellite communications, we all are quite aware of it, but the recent advances such as large phased array satellites, precise beam forming, and adaptive power control. Now, these allow links to unmodified handsets while managing interference with the ground networks. Okay. Now, with a view to achieving a cross-domain solution for radio communication, a tactical data link can be adopted to ensure seamless interoperability among diverse radio systems operating in the tactical battle area, the way we have, because the way they have been procured over a period of time from different sources. Okay. So such a TDL acts as a common digital layer that bridges the homogeneous waveforms, the frequency bands, and platforms, whether it be air, land, or maritime. thus enabling a secure real-time exchange of voice data and situational awareness. And they also reduce sensor to shooter timelines and ensure coherent command and control in complex multi-domain battle environments. The high frequency communication links in the E-band, 71 to 88 gigahertz, they offer a promising option for a low probability of intercept communications due to their inherently narrow beam widths, high atmospheric attenuation, and short effective interception range. The combination of pencil-thin beams, adaptive modulation, rapid beam steering, and low side lobe emissions is what enhances the stealth and resilience against electronic surveillance and jamming. So as a result, these E-band radios are very well suited for secure point-to-point backhaul, tactical command links, and sensitive defense communications, where confidentiality, spectrum reuse, and electromagnetic signature control are critical. Another aspect is battlefield futuristic 6G military-grade private networks, which can provide a resilient, ultra-low latency digital backbone for multi-domain operations by tightly integrating terrestrial, aerial, and space-based nodes. Leveraging sub-terahertz bands, AI native network management, network slicing, and integrated sensing and communication is what provides the private 6G enable real-time ISR fusion, autonomous swarm control, extended reality command interfaces, and secure machine-to-machine coordination. Now, while this is for communications, on the other hand, the EW domain, the counter to it. The satellite-based electronic support measures and electronic countermeasures, what we call it as ESM and ECM, is what provide persistent wide area electromagnetic surveillance and influence from space, unhindered by terrain or national boundaries. These space-based ESM enable detection, geolocation, and characterization of emitters across vast regions, while the ECM payloads, they can support coordinated electronic attack, deception, or denial in conjunction with terrestrial and aerial assets. Now, such systems, they enhance the strategic situational awareness, early warning, and cross-domain EW operations, forming a critical layer in integrated multi-domain warfare. HAPS, high-altitude pseudo-satellites or high-altitude platform systems operating in the stratosphere is what offer a unique middle layer between the satellites and the airborne platforms for ESM and ECM missions. Due to their long endurance and quasi-stationary positioning, they can provide actually persistent regional spectrum monitoring, precise emitter localization, and responsive electronic attack. So thus, their proximity to the battle space is what allows higher resolution sensing and flexible payload configuration. Cyber over RF payloads. This is another thing which can exploit actually wireless links as a vector to deliver cyber attacks, bridging the electromagnetic and cyber domains. So these payloads primarily focus on protocol-aware signal generation, waveform manipulation, and embedded cyber, which can exploit to inject, disrupt, or manipulate data flows over RF links without actually physical network access. So such capabilities actually enable non-kinetic effects like data corruption, command disruption, or system degradation, thus expanding EW from signal denial to deeper cyber physical influence on adversary networks and platforms. Now getting on to the next domain, when we look at ISR, RF-based battlefield sensing that is beyond the traditional radars is by using the passive techniques like signal of opportunity exploitation, emitter geolocation, RF imaging, and pattern of life analysis is what they significantly reduce detectability and vulnerability to countermeasures. So as a result, the passive RF sensing is what provides a stealthy, resilient sensing layer well suited for contested and electronically denied battlefields. Quantum, while there's a lot happening about the quantum communications, but and also into computing, but quantum sensing is something where some more is required, because it can significantly enhance ISR capability. Quantum sensing to deliver ultra precise measurements of time, gravity, magnetic fields, and inertial motion. They can significantly enhance the ISR capabilities. The quantum gravimeters and magnetometers is what can enable passive detection of whether say submarines, underground facilities, and concealed infrastructures without emitting detectable signals. And another version of it, another application, the quantum inertial sensors is what can provide high accuracy navigation and targeting in GPS denied or contested environments. Another major domain now emerging is the cyber warfare and the new domain, which is a new domain and the future battle space, along with the information wars. So what has altered? Today, the line between civilian and soldier actually is almost dissolving, because every civilian using a mobile phone is also becoming a source of information. At the same time, he's also becoming a target. So it's a dual use infrastructure both ways, whether is something which actually creates has large number of implications when we look at it from the military and the security point of view. Okay. Now with all this, so what is happening is, I think we need to look at information warfare, perception management, and narrative control as core combat functions. It is not only just the firepower, but this is what again needs to be looked at, core combat functions. So while I have mentioned to you about some of these technologies, but finally it boils down to what is it that we need to do. So what is that the Indian Army needs? So we have various documents which are there available on the internet, and you can have an access to these documents. We have a TPCR, that's a technology perspective capability roadmap, a tri-service document, which consists of the requirements of all the three services. Then we have a compendium of problem definition statements, the last one which was uploaded in February 25. And it had 81 problem statements in it. We have received good about 794 responses, both from academia and industry. So we are actually now evaluating them, and already decided about 50% of them. The route of development, will be initiating those development projects very shortly, which will be funded by us and say by the government or the army. Compendium of technological challenges is what we launched in September last year for the first time, looking at little bit ahead in the technologies in the near future, in next about 2 to 5 years. It again consists of 41 different technological challenges. The details are not available on the internet, but the list is surely available on the internet. All those who are interested can approach ADB, and then we can share with you that specific technological challenge as per your domain. And this is just to show a snapshot of, say, various technologies, what is given in the technology perspective and capability roadmap under these various domains, which I just now spoke about. There's the communication, EW, space, and various sensing technologies. Okay. And I would like to assure you that when we are giving when we are floating the compendium of problem definition statement, just to quote you some figures of the last version, which was in 23. Out of that, we have initiated 65 various R&D and D&D projects, and also many of them contracted, or because of which they got closed. So that is how we are taking them forward, and not just stopping at launching of the problem statement. We want the solutions, and we want to support the industry and academia in developing those solutions. This is what a snapshot of the various technological challenges which are available. Online also. You can just Google Army Design Bureau. You'll reach onto our web page, and you can get this list over there. And thereafter, you can contact us for the specific one, like I mentioned earlier. While these are already there, but there's a lot in the pipeline also. What is coming up is we're evolving a technology roadmap for US and loitering munitions, giving out good about nearly 30 plus various categories, each one of them having another about 2 to 3 variants. So nearly about 80 to 100 products worth of it in all various domains, whether it be, say, ISR, it's in, say, in targeting, in, say, drone on drone, or any special kind of applications of drones. So that is to give a visibility to the industry and academia to start developing those solutions, so that whenever we need them, then you are nearly ready with those solutions. SWAYAT roadmap, the SWAYAT mission, SWAYAT is what the Indian Army has started for the autonomous development of autonomous systems. So SWAYAT in English implies autonomous. For this, again, there's a roadmap which is nearly under finalization. And that's what we'll be again sharing with the industry. Good about nearly, I think, 60 plus use cases for which you would expect the solutions from the industry in that. And also the R&D roadmap for the academia and various R&D organizations across all domains. What we just initiated the process will take a few months for us to finalize this, but that's another opportunity where the industry and academia and the entire ecosystem can actually participate. So with that, within the given time, I would end my talk here. And once again, thank everyone. Thank you.
Thank you very much, sir. I now invite DG Claus to please join us on the stage and felicitate General Mann with a token of appreciation. No, sir, no questions because we are short of time. So please. A huge round of applause, ladies and gentlemen, for Major General C.S. Mann. Thank you very much, sir. Moving on with the panel discussion. Now to moderate this session, I invite on stage Major General R.P.S. Bhadoria, VSM, Additional Director General Center for Land Warfare Studies. General Bhadoria has commanded a mountain brigade and a division on India's northern border and has held several prestigious staff appointments at Army headquarters. He has